Thank you very much, everybody, for joining again. Today's topic is marine spatial planning and climate change. It's a topic that's increasingly important for marine planners and for marine management for obvious reasons. So today's webinar is to look at where are we with respect to climate change in the sea and how can marine spatial planning start to engage much more with this specific but very, very important topic. Climate change has become an undeniable fact. We're all aware of it, and the evidence that man-made climate change is happening is now very clear. There's plenty of information that indicates how climate change is affecting oceans. And here is a summary of the most important points. So the first one being that the oceans are getting warmer. They're heating up not just on the sea surface, but also throughout the water bodies. Sea surface temperature is a separate aspect because it affects many different species and processes in the ocean. That is then compounded by sea levels also rising as a result of many factors coming together. There are different predictions of how sea levels might be rising in different parts of the world. So sea level rise is not even. It depends very much which ocean and where you live, but it is happening. Also at some speed, and perhaps also slightly quicker than what was expected initially. That then leads to the prospect of land loss, by land simply becoming inundated as time goes by, and also a greater propensity for coastal flooding, because in parallel to sea level rise, there are also indications for greater storminess, stronger storms affecting us, more precipitation generally also, which affects the hinterland, which also contributes to the flooding risk because of water having to find pathways really or runoff into the sea. If that's then combined with a storm surge, for example, then flooding can be very, very severe indeed. And the last point listed here is ocean acidity, which is also extremely important for organisms like corals in particular, who are very severely affected by increasing acidity in the ocean. It affects their skeletons, and it means that they're very much susceptible to damage and are likely to disappear. So many aspects that are relevant for marine management, for the health of the ocean, and also for marine spatial planning, thinking about marine spatial planning being a future-oriented instrument and tool all the way. So how can marine spatial planning respond to the prospect of climate change? And like all responses to climate change, there are two options, which are mitigation and adaptation. And here on this slide lists or are the points that are most commonly actually used in those respective categories, not just in the ocean, by the way, but generally speaking in management. So mitigation is very much a question of pushing renewable energies, for example, but also thinking about carbon sinks. How can we capture carbon and make sure it doesn't go into the atmosphere? And then the second point, adaptation, that really then comes down to the different spatial approaches that we might take, responding to changes in the ocean, responding to some of the threats, but also maybe thinking about more responsive MSP design, possibly also new opportunities that might come because of climate change, and then working with nature in new ways, in slightly different ways than we might be used to. And we'll go through some of these one by one in the following slides. So first of all, before we do this, a quick look at the impacts that really are most relevant for marine spatial planning. We've already seen that there's a number of changes in the ocean, so changes in temperature, salinity, acidity. What does that actually do in a way that could be relevant for marine spatial planning? Well, those factors combined plus others are very likely to lead to shifts in species distributions, in where key habitats might occur. If we're talking about Northern Europe, what's already becoming clear is that some species that are cold temperature species are moving northwards, and that species and habitats that are warm water species are perhaps pushing in from the more southerly habitats, from the more southerly oceans. So there's an impact on ecosystems, and with that, impact on the services we humans take from those ecosystems. So impacts, for example, on the fish we catch, on the type of aquaculture that might be possible. And there's impacts on conservation, on biodiversity as a very direct result of those shifts. We've also already seen that there are likely to be changes with respect to sea level rise. There's going to be a greater propensity possibly for storm surges. That then leads to greater erosion risks, for example, and a whole new needs for coastal protection. So before we come on to some examples, maybe also looking at how marine spatial planning has begun to tackle these challenges, how much do we actually know really about the severity of the problem? What do we know? What's the current state of knowledge? Not that I'm any expert in modelling climate change or in fact in climate change, but just to give you a flavour of how science is trying to pinpoint the significance of the problem is of course through models, through modelling projects. And here's an example from the Baltic. You can see the reference below it, which kind of forecasts temperature changes that are likely in the Baltic Sea up to the year 2100. And you can see that there's a fairly sort of obvious increase in summer water temperatures. Here we're looking at the sea floor. So we're not even talking about surface water temperatures. We're talking about sea floor temperatures here. And you can see that there is, less dark blue and more red as we move towards 2100. There are many projects that are looking at the effects of climate change, Climarine being one of those. And here is just some selected results, again, from the Baltic Sea. And this particular project has been able to show that the hypoxic areas, that is the ones without any oxygen in the Baltic Sea, has grown quite a lot since the 1950s. This is another project that looked at sea surface temperature in this case, and again, different scenarios, different model runs are predicting quite a significant increase also in sea surface temperatures. There's the range between 1.1 to 3.2 degrees Celsius compared to the reference period 1976 to 2005. This particular project also finds that it's very likely that sea ice extent is going to continue to decrease. We are seeing already that sea ice is decreasing, so very likely, which makes perfect sense if temperatures go up, that the extent of sea ice is also going to decrease. There are some uncertainties when it comes to predicting exactly how things might develop because, not least, of uncertainties in terms of freshwater supply, how the wind is going to behave, and global sea level rise. There's also some uncertainty when it comes to salinity projections, how that is going to develop. So here, this particular project has found some trends, but no really clear picture, no really robust changes that we can refer to with any degree of certainty. And there's also some evidence for increasing acidification in the Baltic Sea. So moving on from these more physical parameters, is there any evidence yet of ecological shifts? And here I've brought you some evidence of exactly that from the North Sea this time, where climate models are predicting various changes which then have impacts on primary production, which then, of course, is going to impact on the food chain. So already we can see that cold water species in the North Sea are moving north, and you can maybe just about see that in the little maps that I've put on that slide. Place, for example, has moved out of the coastal regions, in this case of the Netherlands, Germany and Denmark, moving away from the coast towards the colder parts of the North Sea, moving towards the UK, moving into Scottish waters in that case. And that is shown, for example, in the number of plays that are caught in coastal waters in the German EEZ. So these are just examples to indicate this change is actually very real and we are observing its impacts already. And then, last not least, coastal defence. Sea level rise is the key threat. Erosion is also a key issue. It's also becoming obvious that the hard measures that everyone is used to very much in Northern Europe, at least dikes, for example, think of the low-lying coasts along the North Sea, that is actually unlikely to be sufficient in the future. So there's growing interest and growing emphasis of softer protection measures, things like beach nourishment, which of course also come with their own respective implications for marine spatial planning. Now, of course, climate change is very much on the political agenda, and most countries, I would say, have actually set themselves fairly ambitious national policies, mostly to reduce CO2 emissions. So Germany, for example, the target is that all electricity generated or consumed within Germany should be generated in a carbon neutral manner by 2050. Denmark's target is even more ambitious, and there's a corresponding EU target, which has received a further push now under the Green New Deal. So I'm showing this because this has very direct, very clear implications for marine spatial planning, because it directly relates to renewable energies. And it, of course, then implies that there might be changes in the priorities when it comes to how we use our sea space, that new trade-offs might be required, and that new conflicts are also very likely to arise. So climate change is very much talked about in the language of threats, in the language of defending, in the language of mitigation. But of course, it's very legitimate to ask whether there might not even be opportunities associated with it as well. And this is one cartoon that tries to depict exactly that. Maybe some sectors are actually going to find advantages stemming from the changes in the oceans. And the key question there, of course, being, well, is there any indication as yet that countries are responding to the disadvantages or possibly opportunities climate change might bring in their marine spatial plans? So let's have a look at some examples for that next. The first example is Sweden, and I'm presenting this because Sweden has tackled the climate change topic very early. Their point of departure back in 2014, when the marine spatial planning process was still very much in its infancy in Sweden, their point of departure was that climate change will have an impact. It'll impact the seas, and it'll impact opportunities for using the seas in many different ways. And that planning needed to be based on the best knowledge and evidence. And not only that it regularly needed to incorporate new knowledge as it becomes available. And an MSP can actually contribute to more healthy marine ecosystems and can help to mitigate and adapt to climate change. So that was really, okay, that's really the ground assumption upon which MSP would be built. Sweden then did an initial analysis and looked at some aspects, in particular, for example, the role of biodiversity, how that could maybe contribute to dealing with climate change. You can see the role here of climate refuges or carbon storage, the role of energy, renewable energy, the role of coastal protection, and how that then translates into potential conflicts between the different interests and sectors. And here depicted, you see Sweden's illustration really of how they have tackled these potential conflicts. So you see there's always one bubble in the middle, which in the left-hand case is environmental protection. And you can then sort of see how that branches off into potentially negative impacts, potential benefits, other potential opportunities, ecosystem services and other needs. So this is really Sweden's way of trying to determine what are likely impacts, what are likely conflicts. And the conclusions that Sweden drew from that early analysis was that climate change is very much a cross-cutting issue. It's not just something you can put in one box. It's not like a sectoral interest in that sense. And they concluded that in Sweden specifically, and in the context of MSP specifically, the focus should be on offshore wind farming, on biodiversity, and on sand extraction. They also found that many other sectors are indeed affected by climate change, but that it was much harder to predict exactly how that would translate into spatial consequences, which makes it harder to translate into tangible, into specific planning solutions at this particular stage. So that was an example of analysis that a country did fairly early, and I would suggest that some of these conclusions are probably easily transferred to other countries, especially also the last point that, it's still, despite the good evidence we begin to have on the impacts of climate change, it is still quite tricky to know how really is it going to affect sectors in the longer term. So let's have a look at how MSP has already responded to climate change in MSP plans. And I want to look at some more sectoral examples to see where does adaptation come into play, where does mitigation come into play. So the first example to look at is shipping. And I want to look at adaptation first of all, The question there being that if we assume climate change will have the impacts described, are there not going to be new shipping routes? Possibly. Are we not going to have ice-free areas that haven't been ice-free before? Is that not going to be an opportunity possibly for the shipping sector in the future? So an example I'm showing you here is from the German Marine Spatial Plan, which is currently being redrafted. So this is really hot off the press, if you like. It's from the second draft, which has just been published. And there, the tool that's being used is to introduce temporary priority areas or reservation areas to accommodate such potential shifts, because the shipping industry is saying, well, we can't exactly be sure that we may not need certain routes or certain access possibilities. So let's have a way of keeping some of these options open. So it's very much a question of maintaining potential opportunities in the future, and temporary reservation areas is one way of doing it. Another way, which is the example of Denmark, is to argue that shipping corridors should be defined in marine spatial plans, and because the more direct routes ships can take, the more efficient shipping is going to be, which means less fuel, which means less CO2 emission from the shipping sector. So coherence in maritime transport is also a very important contribution that MSP can make. And this is very much the approach that is depicted in the quote on the slide here from the Danish, also the draft, the proposed maritime spatial plan. So shipping, clearly it's possible to tackle climate change or to look at climate change from both the adaptation and the mitigation angle. And the same, of course, also applies to the energy sector. So here, the example, which is not going to surprise anybody, renewable energies, very much the focus of mitigation. Again, I'm giving you Denmark as the first example. You can see here the targets that Denmark has set itself as a nation, so a significant reduction in CO2 emissions. There's a very strong focus generally on renewables as a result of a green transition policy. And there's also, the sort of economic push, Denmark clearly being very interested in having leadership when it comes to the renewable energies industry. You can read through the quote, but the basic purpose is to make sure that there's enough space dedicated to renewable energies in the maritime spatial plan. So this is what it looks like. You can see here that really large areas have been dedicated to renewable energies. You can see that there is mention of energy islands, and that there's also small pockets, really, that's the dark red colour, of existing renewable energies. That's wind farms mostly, but mostly look at the green and the yellow. So really a considerable, quite a huge expansion planned, or at least set out in the Marine Spatial Plan in order to encourage that kind of development in the future. And many other countries have done something very similar, and that's the example from Germany, the neighbouring country. And again, you can see large areas already here are dedicated to offshore wind farming, priority areas set out. And again, you can see the target, and here on the slide, 40 gigawatts, that's the target, the policy target to be achieved by 2040, which translates into considerable spatial needs and spatial occupation, shall we say, by offshore wind farming here. But it's not just about offshore wind, it's also about CO2 storage, for example. And Denmark is acknowledging that in their plan, saying that the North Sea in particular has a major potential for storing CO2, and that's really mostly looking at former oil and gas extraction sites. So that's another way to actually tackle climate change, by making use of these former extraction sites for storing CO2. Moving on to the next topic, the next big topic, which is biodiversity, and the question, what role can that play when it comes to adaptation and mitigation? The general approach that most countries have taken, or the argument that's put forward by most countries in their plans, is that protecting and improving biodiversity helps strengthen the resilience of marine ecosystems in the long run. And here is the example of Sweden. Sweden has translated this general principle into a total of 45 areas that the Maritime Spatial Plan has designated for nature. 35 areas have been identified as being of high nature value, for example, including climate refuges. And Sweden has also given nature explicit priority in some cases over, for example, offshore wind. One of the bigger problems, of course, being that on the one hand, you have the clear desire, the clear priority for mitigating climate change, which translates into offshore wind farming, for example. We've seen the huge spatial implications that this has, but the question is that then going to be at the expense of biodiversity? What's the impact of these developments on nature? And is conservation, is biodiversity always compatible with renewable energy development? It depends on who you speak to. Sometimes the answer would be yes, sometimes the answer would be no. It's certainly a matter that is giving rise to very contentious, very difficult debates at the moment. Biodiversity protection, the example of Denmark. Again, you can see that actually large areas have been proposed here as both conservation and protection sites, and also proposed sites for bird protection areas, for example, or marine strategy areas, which is quite an interesting category as well. And you can see a decided increase also in the percentage of protected areas from 19% to proposed 30% of Denmark's sea area. So this is Denmark's way of contributing to the European Union's biodiversity goals, the biodiversity strategy, and also again arguing that, that this is not just for the sake of biodiversity, but also in order to have resilient ecosystems which then help species and habitats adapt to climate change. Climate refuge, that's an interesting concept that has come up in one of the previous slides. Let's spend a little time looking at those, because that's another matter. It's not necessarily the same as a protected area. It may be, but it isn't necessarily. So what's a climate refuge? Really, when it boils down to it, it's the last remaining viable habitats for a particular community maybe, or a group of species. And here's a definition, which is, okay, it's an area where climate change has not or will not severely affect the habitat or species within a larger area where climate change, as a contrast, has already affected or is affecting the habitat or species. So it's really the last chunk, the last little bit that's left in a situation of climate change where species, where habitats are still finding a kind of last refuge. There's acknowledgement that these refuges are likely to not be in the middle of a distribution of a species or a habitat, but kind of sort of on the fringe somewhere, almost actually already in locations that are unsuitable for that species or habitat. So somewhere tucked away in a corner, if you like. But they can also be locations where the local conditions are such that for some reason there's a greater resilience maybe, or a viable or a healthy presence of the habitat or species is preserved. And it could be that there's, for example, some upwelling going on, or particularly good water quality in an area. So that's the principle of a refuge. And there has been some research as part of a recent MSP project called Pan-Baltic Scope. You can see the report, it's well worth reading. I'm just giving you some extracts from that report here. So that report looks at climate refuges in the Baltic Sea and does some modelling to predict where possible important future habitats might lie. And it looked at eelgrass, at pondweed, at bladderwrack and blue mussel distribution. So here's some results from that report. And if you are interested, if you want to know more, please have a look at the actual report. It's available for download. So here we see the modelling results for mussels, for blue mussels, and you can see the prediction on the right-hand side. You can see that the distribution of suitable habitat for blue mussels is actually changing quite significantly by the year 2100. You can see the little black circles. Those are the ones which are going to be the refuges, I suppose, one could say, that are going to be left over by the year 2100. And similar results were obtained for the other species indicated on the previous slides. And the overall conclusion is that there are certain areas that do stand out as particularly important in the models, areas that would be core areas for those species, the refuges, the kind of last remaining patches that are suitable for those species. And those, of course, should be the ones that ought to be given specific consideration in marine spatial planning, but not only in marine spatial planning, but also in wider conservation and environmental impact studies as well. So modelling like that, modelling potential future distributions or habitat suitability is a really good way of preparing ourselves, of looking ahead also in marine spatial planning, anticipating some of the projected changes that climate change will bring. And Sweden, for example, has already designated some climate refuges in the spatial plan. So it's defined as an area that's important for the preservation of certain species despite climate change. And there are 7 areas that are dedicated climate refuges, one's for herring, 5 for blue mussels, and then 1 combined one. Climate refuges is one aspect that's really, really important. Another one that is very much being discussed is how is climate change likely to affect protected areas? And here's a research paper which I just briefly want to highlight because it used models in order to project into the future likely changes in the distribution of certain indicator or key species on the climate change scenarios. And this example comes from the North Sea, and the target years are 2050 and 2099. And it found that the stability of the distribution areas of the species considered was still given up to round about 2050, but afterwards the distribution area decreased considerably, and that some species even disappeared completely from the protected area. So this really was to look at, okay, MPAs, assuming they are static, are they still going to be doing their job after 2050 if we assume climate change is going to have an impact? And the answer very clearly from this particular modelling exercise is that MPAs in the medium term might indeed become quite ineffective, no longer doing their job properly. But it's really important to carry on monitoring these impacts, these effects, the shifts that might happen to species, to habitats, because protecting certain species, certain habitats in existing MPA boundaries may no longer be possible, and may no longer be possible at all if we think of MPAs as a rather static concept. So that's certainly something to think about. We've talked about the shifts in biodiversity, the shifts in species, impacts of climate change on species distribution. We've thought about climate refuges, the importance of knowing where such refuges might be, the importance of protecting them. We've also considered MPAs, what might happen to marine protected areas. But what about the role of the blue bioeconomy? What about cultivating and growing particular species, not just possibly with a biodiversity benefit in mind, but also maybe with an economic benefit in mind, or with a climate change mitigation thought in mind. So these are examples that can in fact fulfill multiple benefits. So if you think about mussels, seaweed, seagrass beds, maybe also some other species in the future, growing them, enhancing them, restoring habitat, creating new habitat for them can in fact help reduce CO2 and also lead to economic benefits at the same time. Let's have a look at seagrass. First of all, seagrass is a very important species because it is very effective at taking up carbon from the atmosphere. It's quite impressive. The statistics reading here that it can do that 35 times faster than tropical rainforests, for example. So this is an example from the UK, from Wales, specifically where there are plans to actually plant seagrass beds to actually really expand seagrass habitats for the specific purpose of capturing CO2 from the atmosphere. The added benefits of doing that is that seagrass habitats can also offer protection from coastal erosion, can produce oxygen, can absorb nutrients, and provide habitats for many fish species. Here, for example, it's cod, it's placid pollock, but also, of course, then for many other invertebrates and other species at the same time. So it's an all-round good idea, one would imagine. And the same really applies to mussels. An interesting finding is that mussels are also actually very good at capturing CO2. The same applies to oysters, for example. And just to give you here some ideas, some statistics of what has been calculated, quite considerable amounts of CO2 that can be captured and can be reduced or taken from the atmosphere, so to speak. Whenever it comes to projects like this, targeted restoration projects or habitat creation schemes, the challenge is that it's all about finding the right location. And that is not as easy as it might sound. The problem being that any kind of restoration or new creation of habitats is in fact not cheap. It's likely to cost a significant amount of money on the one hand, but also time and effort, and it requires suitable habitats. So it's clear that you can't just pick any old site that just happens to be available or not being chosen by anything else. But there has to be a consideration of how likely is it that that particular site is going to give me restoration success? So is the seagrass really going to grow well in that site? Is it really going to produce enough mussels or oysters to produce an economic benefit? Is it going to be worthwhile, in other words? So it's very, very important to be strategic when it comes to that site selection in order to maximize the benefits and to minimize the costs. And that has also been shown in some research on that topic. And here's just another example. The same, of course, applies to mussels. There, the key criteria are that mussels need to be able to find sufficient food. The temperature has to be right. Water movement has to be just right. There shouldn't be too many predators. You should always consider what's the impact of cultivated mussels on wild mussel populations. Are the two going to merge, or is there going to be any problem when it comes to wild stocks, for example? So it's again, the choice between where's the most suitable area, what are the logistical costs also for maintaining a mussel bed and harvesting, and what are the marginal economic costs of all the other measures that have to be considered. So any kind of habitat creation, any kind of restoration is well supported by suitability assessments, by habitat assessments. Here's one example of a classification of which habitats perhaps might be suitable for where. Or this one here, which depicts the number of species and plants that occur in different regions of the Baltic. It also depicts whether the coastline is a rocky or whether it's a sediment coast. It also depicts salinity gradients, for example. So that's also an indication of, basic suitability for different types of species, different types of habitats that are likely to thrive or not thrive in those parts of the Baltic Sea. Or we have this particular example, that's for seaweed, different species. And again, you can see it's an assessment of the production potential expressed in percentage growth per day. Red being a very high growth per day, productivity, blue being pretty low productivity. And again, you can see that this is quite varied across the Baltic Sea, depending on the species and depending on many environmental factors, of course, to do with temperature, salinity, etc., habitat, seafloor, and so on. Now, the big question, of course, is have marine spatial plans already allocated space to the blue bioeconomy? And you can see the comparison here across different countries that border the Baltic. And the picture is pretty varied, with only Denmark allocating a specific area to the blue bioeconomy. Other countries are kind of indirectly making room for the blue bioeconomy by proposing areas for more general use, for example. And you can also see that there's a difference between the EEZ and the territorial waters of countries. So that's an interesting picture and an interesting question actually to ask also, are MSP plans already thinking ahead? Are they already giving space explicitly for those kinds of activities. Here's the example from Estonia, the draft maritime spatial plan. And you can see that there are areas, policies that encourage the development of shellfish and algae cultivation in areas that are naturally suitable for those kinds of activities, and also outside of areas where that use is not permitted. So again, have a good look at these maps. It's a good example of a country that's already tried to take account of these new demands. The last part of today's webinar, we look at summarising possible action pathways for marine spatial planning. And I'm mostly referring to a paper that was published not long ago in Nature Sustainability. The first author is Catarina Ferral Santos. It's well worth reading. It's a really good summary of how ocean planning, or marine spatial planning if you wish, could integrate climate change concerns. Based on a very thorough global review of literature and MSP projects and existing plans, they've done a lot of work really looking at the knowledge, the planning that's available to date on climate change. So the first thing they are saying in their paper is that it's important to acknowledge climate change and its impact in marine spatial planning policies, so in the plans themselves and in the specific supporting policies, and that it is very important to do more than just give general and often rather vague statements. You can see here the quote from that paper, which says that yes, some plans are already acknowledging climate change is happening, but it's not terribly specific. It's just really saying, okay, climate change is kind of happening. It's rare that specific measures and specific actions are being proposed. Another possible action pathway is to use climate change much more specifically in scenario exercises, in envisioning processes. Another webinar which talked about MSP instruments mentioned the use and the usefulness of scenario approaches, so visioning exercises, any kind of forward-looking planning. Include climate change, maybe even do specific climate change scenario exercises, visioning exercises. Another one, of course, which we have seen already in the past half an hour, is to make good use of modelling tools, of mapping tools, to depict and to actually show what changes the ecosystem might experience, how that might impact ecosystem services, how human activities and the distribution of human activities might be affected by climate change. So make use of these visualization tools, the modeling tools that are available, bearing in mind, of course, that no model is perfect, that there are many uncertainties associated with models, but at least it's perhaps a way of thinking about the future, about potential possible futures. Based on that, a bit like the climate refuge analysis we've seen, identify those hotspots. Maybe it is the climate refuges that are important, but maybe also other hotspots of change. Maybe where activities might change drastically because a new activity is possible for the first time. The type of activity might change. The composition of activities in space might change. And develop climate-related risk analysis and vulnerability analysis. And that might be very much a sectoral thing, because the risks for different sectors are, or may be quite different, might be quite specific. And so it's important to look at each sector in isolation to see how that might pan out, but then of course also bringing it back together to get the full picture. And there are tools available that can help you do that, especially in case of the first bullet point, the modelling, the mapping, but also the risk assessment, the Symphony tool that was developed for the Swedish Marine Spatial Plan, also Mark Zahn with zones. These are examples for modelling tools that can really support those kinds of processes. Future-proofing environmental concerns in marine spatial planning. That's really asking, what's the future for species, for ecosystem services in the planning space or in the wider marine environment? Where should our focus be when it comes to future distributions of species? Which are the new endangered species of the future? What about existing protection areas? How can we rank the importance of certain species over others? How can we make sure that we know which values are going to change in what way? What flexible approaches can we conceive of when it comes to area-based conservation? And how can we model future services also, so the benefits that we draw from the ecosystem, rather than just looking at key species? So this is really, questions that are important to be asking ourselves, not just once, but actually repeatedly through the various iterative MSP cycles. And MSP, of course, plays a role in designing measures that can help improve future conditions in the sea. Considering more dynamic ocean management, I'm putting that here, even though that clearly is a very difficult debate, which is likely to become more prominent in the future. Dynamic ocean management, moving away from the slightly more rigid approaches that marine spatial planning is currently taking, especially when it comes to fairly fixed zoning schemes. Are there maybe ways conceiving of spatial planning as a more dynamic management tool, using real-time data, for example, using more flexible depictions of ocean resources and changes in the sea? Maybe you can come up with ideas of what that might be like, what opportunities, what options one might have for such more dynamic approaches. But then there's also anticipating change, anticipating what might happen by already designing zones with future change in mind, kind of as a precautionary tool, as a precautionary instrument. And an example from the Netherlands is that they've already now designated sand extraction zones, anticipating further coastal protection needs in the future, so securing those areas already now, thinking that in 30, 50, 100 years, that sand, those sand extraction, that resource is going to become really, really important. Last not least, of course, adaptive management, absolutely important to regularly revise MSP plans, other types of planning, real-time data, we've already quickly touched upon that, more flexible management, more flexible protection management in particular. So what else can be done in terms of future-proofing marine spatial planning in the sense of being able to deal with climate change in the best possible way? One is certainly to invest further resources and time into capacity building. Also, when it comes to stakeholders, involving stakeholders, making sure that they are part of that debate, making sure that they understand the changes, the need for adaptiveness, especially involving business stakeholders. It's also useful to focus much more on multiple use in order that the blue economy can become more just and nature-based, also anticipating the impacts of climate change. And then, of course, making sure that there's relevant data that future MSP builds on, the data that is important for the planning area. I want to leave it there, actually. Dealing with climate change is nothing that is ever really finished. Climate change, we don't know exactly how it's going to affect different sea areas. We don't know exactly what the challenges are, when they might hit us, how they might hit us. So it's important to always remember the adaptiveness, the cyclical element of MSP, the necessity to keep engaging with science, to keep engaging also with modeling, with the future forward-looking instruments that are available to us, and above all, to keep that conversation open with stakeholders, to listen to their concerns, to listen to their ideas, to also bear in mind how they might wish to adapt and change in response to climate change. And last not least, climate change is one factor amongst many that MSP planners have to consider, but it's likely to become a more important one as time goes on. That's it from me for today. I thank you all very much for listening.